8255. What is 8255? 8255 is a IO interface. It's an IO interface, right? What is this? Hope you remember in my previous class, I told you that between microprocessor and IO devices, you have an interface which will behave like your buffer and latch. Which will behave like a buffer and the latch. Okay? And this device altogether available in another integrated circuit, okay, which is called as programmable peripheral interface. Programmable peripheral interface. Now let us see what it has. See, in this slide you are seeing its pin diagram. This is an integrated circuit and you are actually seeing the pin diagram of this. Okay, now 8255 IC pin diagram. What is there in this? First, have a look. It has got 3 ports. More importantly, it has got 3 8-bit ports. 3 8-bit ports. Okay, what is the 3 8-bit ports? I said 3 8-bit ports. Okay, you have port A, which is 8-bit port, port B, which is also an 8-bit port, port C, which is also an 8-bit port. So what is the capacity of this port? What is the capacity of this programmable peripheral interface? It has 3 ports, port A, port B and port C. Okay, all these points you need to remember. What is the function of this port? Tell me. What is the function of this 8-bit port? What is the function of this 8-bit port? Come on, tell me, what's the function of this 8-bit port? What a normal port does? Tell me. You have ports here, right, in Dubai, right? What that port does? It receives the data and sends the data. You all know about it, right? In a similar way, port A can send 8-bit data, also it can receive 8-bit data. Similarly, port B can send 8-bit data, port B also can receive 8-bit data. So this data exchange will happen through this port in this programmable interface. Have you understood now? Okay, it's very simple. It is not difficult. If you open up your mind, just concentrate on my lecture. I'm sure 100% you can understand. Otherwise, if you are looking at your mobile phone, your mind is somewhere, you will never understand. Even Einstein, the person who invented this IC also comes here, you will not understand. That is a rule of nature. Okay, I don't want to tell this again and again. Okay, in every lecture you can find this. That's going to be a trademark for my videos. I don't need any copyright other than that for my videos. Fine. Okay, good. So as I told you that 8255 has 3 ports and that port, each port is 8-bit. That means 8-bit data can be given out to the IO devices, or you can take 8-bit data from the IO devices. There are 3 ports possible. I understood this. We'll see about the characteristics of each and every port, right? But main thing you have to see that 8255 has how many ports? 3 ports. Port A, see here. Port A. Where is port A? See. Port A, 4 bits are here. Where are other port A 4 bits? Here. So pin number 1 to 4 and pin number 37 to 40 are 8-bit port. that is port A. Through this pins, you can give the data out to the IO, or you can take the data from the IO. Similarly, you have port B, can you see? Pin number 18, 19, 20, and this is port B. And you also have port C. See, port C. This port C. The majority of the pins in this are all your ports. Okay. Then you have VCC as usual. VCC is there. VCC. And definitely, how do you get the data from microprocessor? From data line only, right? So it has got how many data lines? Tell me. It has got 8 data lines, that is D7 to D0. It has 8 data lines. This is connected to a microprocessor. This is connected to microprocessor. Now you tell me, suppose a microprocessor wants to receive 16-bit data. Can I get it from this 8255? Can I get it from one 8255? Not possible. You have to use two 8255s. You make one 8255 as a even address, another 8255 as a odd address. At a time you can list the data. What is the meaning of at a time? What is the technical one machine cycle? Exactly, one machine cycle. Right. Right now we will study about only 8-bit data. We'll try to connect only one 8255 and we'll see how can you connect LED and other things like that. I understood this much. Everything is fine. Okay. Then see here, it has got chip select. What is the meaning of chip select? Chip select. You have done so many chip selects. To select this chip, to enable this chip, your chip select has to be low. Idea CS bar, right? Exactly, it is low. CS bar. Okay. Now, can you tell me what the read bar signal? It's also connected to read bar signal of microprocessor. Yes or no? You have done your protease. Yes or no? You have drawn protease, right? When you drawn protease, you know all these things. You have used all these things. Your read bar signal. I will come to A1, A0 later. You have write bar signal. What is write bar signal? If you want to write data into that from the microprocessor. What is reset signal? I will tell you about reset signal, don't worry. What is reset signal? I will tell you reset signal. Reset signal is something which will reset the programmable data inside 8255. So I'll tell you. This 8255 has got one register inside. It has got a register inside. What is the register? It has got an 8-bit register inside. What is the meaning of register? If I say that it has a register inside, what is the meaning of that? The storage. Right? That means using that 8-bit register which is available in this 8255, you can program it. You can program that. Okay? And that register content can be reset. What's the meaning of reset? Like 0. Right? Using reset signal. Understood this? Okay? So then you have ground as usual. What is this A1, A0? What is A1, A0? Very important. Very important. Okay? A1, A0 is very important. Why A1, A0? Can you tell me how many ports are there in this? 3 ports, right? Port A, port B, port C. Right? Okay. Now, to address these 3 ports, how many addresses are required? 2 addresses. Right? 2 addresses are required, right? So that's what this A1, A0. The A1, A0, actually, this A1, A0 is going to decide what is the address of port A, what is the address of port B, what is the address of port C, and also what is the address of control register. Right? I told you that inside this there is a control register. That's an 8-bit register inside. That's also storage. Right? And you have a port A, you have a port B, you have a port C. So there are 4 components in this where you can put the data. Right? So to select out of these four, whenever you want to use that, we use this address lines. It will be selected through this A1 and A0. I have understood this. Okay. The address lines of the microprocessor is going to select port A or port B, port C or control register. Have you observed something declared in your program when you do this last four experiments? Right? You have port A address, port B address, port C address. There's something control register. Yes or no? How many of you observed it? Do it. The companies are going to come. You have experiments coming from courses also. Not the same question, different question. You have to draw. Your drawing will not be given. You have to do that. Have you understood this? Okay. So physical appearance is only 2 marks out of full marks. 2 marks. Okay. If you are not able to do anything, only physical appearance will only get 2 marks. You want to get 2 marks, or you want to get full marks by doing it. It's left to you. Have you understood this? So start studying from now itself. Okay. So now every pins we have discussed now. Let us see how to use this pins. What you see here, this is the block diagram, internal structure of 8 to 5. Okay, internal structure. What is there inside this? See, there is a port A, port B, and port C. See this. See, how can we use this port A, port B, port C? Try to understand this. Port A, there are two groups of ports. Say port A, port B, port C are divided into two groups. Okay. You have a group A ports and group B ports. Okay. See, port A is full 8-bit. It's full 8-bit. If at all you want to send 8-bit data, complete 8-bit data, you can send it through port A. Okay. Or port B. Okay. Port A or port B. If you want to send a complete 8-bit data at a time. Okay. Now suppose, assume that you don't want to send 8-bit data. You want to send only 4-bit data. Right. In such cases, your port C is divided into two ports. One is upper port C and lower port C. Okay. Try to remember this. The three out of three ports, port A is completely one 8-bit port. Port B is completely another 8-bit port. But port C is divided into half upper and half lower. Okay. That is what this about your ports. This is the output side. Okay. In this place, your IOs are connected. In this place, all the IOs are connected. Hope you understand this. This side is your 8086 microprocessor. This side comes your 8086 microprocessor. In between, you have this very interesting fellow called as 8255. Now, see what it has. You have a control, group A control, group B control, and these are all part of control lines. See here, read bar, write bar, A0, A1, reset, chip select. All these are part of control logic. Right? And definitely you are connecting to the data bus of the microprocessor. That's where you get the data from microprocessor. Have you understood this? Okay? That's where you get your data from microprocessors. Okay? Microprocessor will send the data, right, through this 8255 through some port to the IO devices. Suppose microprocessor wants to get the data, it will come through one of the port here, and then it will be received by the microprocessor. All of you understood this. That's why you are done in your last 4 experiment. Okay. Now, see, I told you about the requirement of address. Okay. Along with that, chip select also plays an important role. Right? Chip select, when chip select is 0 for 8255, then only that particular 8255 is selected. That means it is into the use. Have you understood now? Okay. Now see here. When chip select is 0, A1 is 0, A0 is 0. This is where it works. Okay. When A1 is 0, A0 is 0, that means what is selected? Port A is selected. Fine. Similarly, chip select is 0, A1 is 0, A0 is 1, port B is selected. Right? Now similarly, A1 is 1, A0 is 0, port C is selected. That means if you want to access port C, you have to make your A1 1 and A0 0, then you do whatever you want. Okay? Then similarly, for accessing control register, your A1 also should be 1, A0 also should be 1. Right? So what will be the address for this? See, your address line is how many bits, tell me? 20-bit address, right? Okay, but here you have only A1 and A0. What about remaining address lines? It will be there. It will be there. Microprocessor generates 20-bit address. Out of that, 2 address lines are used. Right? So I can say my address, I say FF, F 0. I'm writing 20-bit address. 20-bit address. Definitely, it will be divided into your code segment and other segment. That's always there. Okay. Now, normally it will be four digit. Okay, 4 digit. Okay. Along with the segment register value, it will be 20 bits. Okay. So you in the program you have always written 4-bit address, port address, right? Yes or no? Yes. 4-bit port address. Okay. So then you have FF1, FF2, FF3. See, this is the 20-bit address. Right? So now this corresponding to which port? Port A. This corresponding to port C. This corresponding to. But when the program we use only 16-bit. But when the microprocessor generates it, it will be 20-bit. Have you understood this? Okay. Now this is about your programming part. Okay. What is this? There are 2 types of transfers. Simple transfer, handshake transfer. What is this? What is the difference between this simple and handshake? How can you guess the answer? Suppose if I say there's the data exchange, right? There's the data exchange, right? What is the simple transfer? Handshake. Handshake is both sleeping and right. Directly गाली देना और बुला के गाली देना. How many of you are here? I don't know. What's the difference between simple transfer and handshake? Hope you understood. Right? Okay. So those who doesn't know Hindi, I think everybody know Hindi, right? So we can understand this. Okay. So direct transfer, you send the data. That's all. Right? Without taking permission from the microprocessor. Just send the data. Right? Now, handshake. Handshake means first it will check the device or microprocessor. Is it ready to take the data? Then transfer. After transfer, check if data received correctly. Right? That's the way a normal transfer is done even today in your network. Right? This is nothing but roads without traffic light. This is road with traffic light. Which is better? Handshake. Okay, you understood the difference between simple data transfer and handshake. This is called a simple data transfer or handshake. Okay. Okay, now there are two types of transferring the data. Okay, I can give many examples about this. Okay, one is polling, another one is interrupt. Right? One is polling, another one is interrupt. I can give an example, very practical examples. In the examination hall, you are writing exams, right? The invigilator will carry addition sheet and go to everyone, ask, do you want post addition? Do you want addition? Do you want addition? Do you want addition? Right? Normally, some examiners do right. Some invigilators do that. I have seen that. I have done it sometimes. Okay. That's called polling. Right? So polling. Suppose I don't do that task at all. Instead, the student will say, sir, I want addition sheet. Then I will go and give him the addition sheet. That is nothing but right. So microprocessor does the polling. It will check every device, it has any data or not. There's a data it will receive. Otherwise, device itself will interrupt the microprocessor and sends the data. That is called as interrupt. So the data exchange between a microprocessor and the I/O port can happen either in polling. Polling method means microprocessor will check each and every sensors connected, whether it has any data to receive. Right? That's one method. Otherwise, suppose temperature sensor which you connected has some data to transfer to microprocessor. It will send an interrupt, as we discussed in the interrupt topic. Right? Then microprocessor will say, yes, this is from temperature sensor, run that interrupt service routine to receive the temperature. That's all. That's interrupt. You have polling method and interrupt. Okay. Remember these examples which I gave you. You can understand it in a better way. Okay.
So this is for both read and write.
Both readers. Both. Right. Suppose if some sensor wants the data, you send an interrupt to the microprocessor. Say that I want this so and so data to receive. So there will be a separate interrupt service routine associated with an interrupt. Microprocessor immediately stop doing whatever it does. Your instruction pointer will be loaded with the interrupt service routine. Right? It will execute. I have understood this. Okay. Now, this is very important. This is very important. Very important. Why I am telling you? Because this is where you program, you set up your 8255. This is where you set up your 8255. Now, question comes. Sir, do we have to buy this? Throughout this entire microprocessor, now actually there are so many microcontrollers you have to use. Okay? There are so many keyboard microcontroller, interrupt microcontroller, so many, right? But unfortunately, this syllabus has only 8 to 5. Right? Has only 8 to 5. Only one microcontroller you have to use. That is 8 to 5. So you are bound to remember this. Right? Bound to remember this. Now, the question comes, what is this? This is where a control word. It's called control word. I told you there's a control register, right? There's a control register inside 8255. What is the purpose of that? It is not kept as simply over there. It is going to keep 8-bit data. What is 8-bit data? That 8-bit data is nothing but your control word. It is called as control word. Okay? Control word. This is the control word format. Right? See this, the 8-bit configuration in this can be anything, right? You have how many options? If I say 8-bit, 2 to the power of 8 options are there to set it, right? But you need not remember 2 to the power of 8. Only few combinations are enough for this. What is that? See here. This is your most significant bit of control word. This is your least significant bit. Now, D0. Let us start from D0. Least significant bit. If D0 is 1, then your port C lower behaves as an input port. See, this port can be either input or output, right? But when we use the ports, we have to program it. You have to set it up, either input or output. So how do you set it? By using this D0. If D0 is 1, port C lower works as a input port. If it is 0, it works as a output port. Similarly, D1, the next bit, it's corresponding to port B. If the port B to be used as an input port, then it will be 1. Otherwise, 0, it behaves as a output. Now, D2, come to D2. D2 also tells about different modes of operations. This 8255 can be used in different modes. We'll discuss about what is that mode 0 operation, mode 1 operation. Right? It can be used in either mode 0 or mode 1. Okay. Suppose if you want to use this port B in mode 0 operation, you make it 0. Right? Suppose if you want to use port B in mode 1 operation, use 1. Have you understood this? Okay. Now, let us come to D3. Let us come to D3. Okay. D3 corresponding to port C upper. D3 corresponding to port C upper. So, port C upper, if you want to make it as an input port, make that D3 bit as 1. If you want to make it as an output port, make that port as a 0. Similarly, come to D4. D4 is set to 1. When you want to use port A as an input, it is set to 0 when port A behaves as an output port. Similarly, see here, port A can work in multiple modes. Okay, port A can work in a multiple mode. Okay, so when number of modes are more than 2, definitely you have to use 2 bits, right? That's why when D5, D6, that is D6, D5 is 0, 0, your port A works in mode 0. Similarly, if D6 and D5 is 0, 1, your port A works in mode 1. And similarly, it is 1x. What is the meaning of 1x? Either 1, 0 or 1, 1. It is mode 2, and at that case, you are using your port A, okay, in mode 2. Right? Now you see, last one, what is this? Very important. Okay, there are 2 modes. One is bit set reset mode or IO mode. This 8255 can be used in 2 major roles. It can be used in 2 major roles. One is called as IO mode, and the other one is called as bit set reset mode. We'll see what is the bit set reset mode. Okay. So whenever this microprocessor, this 8255 is used in a IO mode, this D7 goes to 1. Otherwise, D7 goes to 0. That is bit set reset mode. We'll see what is bit set reset mode. So have you understood about this control word now?
Sir, here port C lower, port B, all are 4 bits, and how are we using D0 as port C lower?
My dear, you are using port C either output or input. Why you want more than 1 bit for that?
So which bit will we choose?
It's not something to do with the bits. You have port C, right?
Yes.
Port C upper. Port C upper, how you are going to use entire port C as a output or input? You have to use at a time. I've understood this. Okay? That's where this bit comes. Similarly, port A. Port A is 8-bit port, right? Right. The entire 8-bit port, all 8 lines, has to be used either as the output port or input port. Have understood now? Only 2 options you have, right? If the option is 1, entire 8-bit port, that port A is used as a input. If it is 0, it's output. That's the way it goes. We are going to do a lot of examples for this, right? If you are highly attentive without using your mobile phone, keeping inside, right? And if you do all the questions, all the problems, I'm sure you don't need any other preparation for this. Your compre starts from 30th, right? When is the compre? When is the compre exam? 29, right? 29. It's on Saturday. Monday. Monday, right? Monday. That's on May 29th. Right? How many days are there?
Not 20.
Yes, that's why I'm telling you. This class is something which can help you. Concentrate here. Okay? So now this is the control word. And control word plays an important role here. This is where you make your port, all the ports either upper or either input or output. And also which mode you are going to work. Or you are going to see whether this 8255 is used in IO mode or bit set reset mode. Have understood this? Okay. So this control word, very important. Keep it in mind. Okay. If required, we will give this in a question paper itself. Only format we give question paper itself. Okay. So knowing control word, now we'll see what are different types, different modes. Different modes. Okay. I told you that your entire 8255, the D7 bits decides whether to use the entire 8255 in bits set reset. This is bit set reset. This is bit set reset. Or in the IO mode. Try to understand clearly what is the difference between bit set reset mode and this IO mode. Okay, very clearly, if you understand, you can do a lot of things in this. Okay. In bit set reset mode, this will affect only to the port C. The bit set reset mode is only for the port C only. Port C only. When your 8255 used in bit set reset mode, by making D7 as a 0, your 8255 works only through port C. That's all. Port A, port B is not going to use at all. Right? Now, when D7 bit is 1, that is IO mode, at that time you can use port A, port B, port C. But what is the difference between these? What is the difference between these? Right. That is what very interesting concept it is. Listen carefully. Listen carefully. When the D7 bit is 0, okay, your port C, there are 8 lines in port C, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. There are 8 lines of port C, right? In this mode, which is called as bit set reset mode, it is possible to individually access these lines of ports. Have understood this? Individually control these lines of the port C. That means, suppose if I want to make, this is your port C 0, port C1, port C2, port C3, port C4, port C5, port C6, port C7. Suppose I want to do only port, I want to send only low or high only in port C, and I don't want to touch other lines. I understood this. I don't want to touch anything. I want to do only port C3. So I will either send 1 or 0 to port C only. In such cases, you have to configure your 8255 in bit set reset mode. Bit set reset. That means when your 8255 is used in bit set reset mode, by making D7 as a 0, only port C individual lines can be made high or low. Have understood this? Right? You have the control over each and every line separately. Have understood this? That is called bit set reset mode. That means every bit individually you can set or reset. Have understood this? But that is not possible when you use it in IO mode. You cannot have access to individual bits. If at all you want to send data, you have to use entire port C, entire port A, or entire port B. So in IO mode, you can use port A, port B, port C, but you cannot individually set or reset the lines, each and every lines. That's the difference. Have you understood now? Okay. So I'm repeating once again. D7 bit is very important. It sets your 8255 either in bit set reset mode or IO mode. In bit set reset mode, you can individually access the port C lines. Individually, you can make high or low. I've understood this. Okay? But in IO mode, you can't do that. If you are using port A, you have to use all 8 lines at a time. If you're using port B, all 8 lines at a time. If you're using port C, you have to use all port C at a time. I've understood this. This is the difference between these two. Okay. When your 8255 is used in IO mode, it works in a different mode. Right? You have port A, port B, port C. Right? See here, mode 0. This is the mode which you are going to use extensively in this. Okay? Mode 0 is simple IO mode. Simple IO mode. All port A, port B, port C can be used in simple IO mode. What is the meaning of simple IO mode? Simple. You put the data, get the data. Put the data, get the data. That's all. No handshake. Just put the data, get the data. Put the data, get the data. That's what mode 0 is. That's what you're going to use now in different examples. Okay. Mode 1 is for handshake IO. Okay. Now you see here, your A port and B port is used for transfer. Okay, data transfer. But port C is used for handshake in this case. See here. When microprocessor works in IO mode, and that also in mode 1, it's a handshake IO, and port A and B transfers the data. Who is going to make a handshake? Which port? C. Port C is going to make that. Okay. Mode 2, it is handshake bidirectional IO. What is the meaning of bidirectional IO? In this, you can set it either out or in, either only out or only in. Okay, right? But in this mode, okay, you can set it a bidirectional mode. Your port can either be sending or receiving. Both it does. I understood this. Okay, that is mode 2. That is port A does a bidirectional. Your port C once again does the handshake, and port B works in a mode 0 and 1 like that. I've understood. These are different modes of operation. I've understood this. Okay. So accordingly, you have to use based on the requirement. You can see here. For example, suppose if your 8255 control word is something like this. Okay. 1, 0, 0. You see how exactly it behaves like. 1 means it is IO mode, right? What is the meaning of 0, 0? It is mode 0, mode 0. Right? Okay. We can study this by using proper examples. Now, see here, this is an example. Okay. Now, see this. What is the mode and IO configuration ports for port A, port B, port C of an 8255 programmable peripheral interface? It's also called as microcontroller. After its control register is loaded with 82. Can you tell me now? Okay, just remember, can you in your book, can you just write this control word? Now you tell me what is the configuration. I will come to the format, don't worry. 82 means how much? This is your D7. Okay, I will come back to this. I will come back to the format. Okay, I will just remove all the things now. I will come back here. Now you have to tell me now 82. 82 means how this 8255 is configured? You tell me now. You have to tell me. I will not give the answer for this now. 82 means what? This is 1, right? 0, 0, 0. 0, 0, 1, 0. Now tell me. Tell me, come on. Port C is, tell me. D0 is 0. What is the meaning of D0, 0? Port C is configured as output port. Yes or no? Come on, to tell this much, why you are still struggling? I told you, right? How does your 85 behaves based on the bits in that? Why can't you tell this? Okay, now what about D1 bit? So port B is input port, right? D1 bit is 1. D1 bit means your entire port B is behaving as a input port. That means it can just take the data from the IO. Fine. Okay. What about D2? What it says? What is in port 0? Port 0? Port B is in mode 0. Input mode 0. That's enough. Okay. What about D3? What D3 indicates? This is port C lower. Okay. Similarly now, port
C upper.
Port C upper. So what about port C upper now? Port C upper is output port. It's an output port now. Okay. What about D4? What D4 says? Tell me. Port A output mode. Port A is configured in output mode. What about D5, D6? It is 0, 0, right?
Yes.
What it indicates? You are working with mode 0, mode 0. D7 is 1. What is the meaning of that? It is working in which category? IO category. This is IO mode. That's all. That's the answer for this question. That's the answer for this question. This is the answer. I have already given the answer for this. Check. Right? Take down the answer. This is the answer. D0, D0, D1, D2, and see what are the remaining one? D3, D4, D5, D6. What exactly it shows. Fine. So have you understood now? Right? So have you understood? 85.5. Share this. Can you memorize? I'm asking you only. Huh?
Yeah.
Can you memorize? Yes or no?
No, sir.
Why no? Why not? Huh?
Sir,
Suppose if I said you have to memorize, you will do it, right? Why no? There is only one table you are giving.
There's so much stuff.
Not so much. You have to memorize, my dear. See, when you get confused, when you have multiple microcontrollers in this microprocessor course, normally we used to teach multiple microcontrollers, not one. And every microcontrollers have control word in it. Right? You have a control word for 85.5, you have a control word for 85.3, you have a control word for 85.9. You have different control words. The students cannot remember all. That's a place we give this control words. Here you can, right? I understood this. Okay. Okay. Just answer the number. So we will stop here and we will start with the. I'm just sending you this lecture. I don't know how many are watching it. All genius people. Okay, fine. Ishan, Aditya, Prakriti, absent. Deepthi Gaur, Larissa, Marvin,
Present, sir.
Hitesh,
Yes, sir.
Zubair,
Yes, sir.
Mubashir,
Yes, sir.
Nagendra, Johan Girish,
Yes, sir.
Mohammad Sinan, absent. Dhairya Patel,
Present, sir.
Vivek, Rishikesh Vivek, Alex, absent. Nimish,
Yes, sir.
Aryan Ramabhadran, absent. Dharma,
Sir.
Saini Suraj, Ramakrishnan Kailash,
Yes, sir.
Naina Siklani, absent. Said Abdullah, Paridhi, Jaskaran Singh,
Yes, sir.
Sriramurthy,
Present.
Malvika, absent. Aryan, absent. Amit Tanishavit, absent. Vishnoy,
Present, sir.
Rajdeep, yes. Rishikesh, absent. Sanjay, Ameya Sanjay, absent. Adil Shafi, absent. Only 50% of the class comes every day, right? Prathamesh,
Yes, sir.
Venkat, Suleiman,
Yes, sir.
Prakhar Singh, Janvi,
Present.
Ishan Kurian,
Yes, sir.
Varshita, Mustaba,
Yes, sir.
Varshita is absent, okay. Shifa, absent. Munib,
Yes, sir.
Uday Shankar,
Yes, sir.
Ved,
Yes, sir.
Sai Shri, Lynn, absent, Lynn is absent. Uday Singh, absent. Anand Bhumi,
Present, sir.
Yashita,
Present, sir.
Rais Hamad,
Yes, sir.
Rushil,
Present, sir.
Sharashwan,
Present, sir.
Par,
Present, sir.
Pratik,
Yes, sir.
Par present, Par,
Sir. Okay.
Ritik,
Yes, sir.
Nupur,
Yes, sir.
Nikita,
Yes, sir.
Sofana,
Yes, sir.
Zaid Mohammed, Saransh,
Present, sir.
Harshit Bansal,
Yes, sir.
Radhika absent, Varnika, Ashwin,
Present, sir.
Sneha, absent,
Okay.
Sania,
Yes, sir.
Nihal.
Yes, sir.
Right.